At the where? To the right. Which one? At the 1? Yes. Because it's how many standard deviations? It's 1 standard deviation. It's not 0.5 standard deviations above the mean. It's 1 standard deviation above the mean. So what goes here? How do I figure out what 0.5 standard deviations above the mean is? Minus 5? Minus 2.5. Why minus 2.5? Yeah, this is half a standard deviation, so we're going down by half. So 73 minus 2.5, and we get 71.5. 71. 71.5. 70.5? Minus 2.5. Yeah, 70.5. And if we do it one more time, what do we get? 60 up. Subtract another 2.5. These are all 2.5-inch steps each line. So we subtract another 2.5, 68. So what is the mean score on our test? 68. So even if they don't give you the same kind of thing, we can still work backwards and figure out where we are in the curve. Okay. See, we'll come back to this one if we have time, but the first slide, that 2.1, that's just going to be a kind of a review question. We already did that in the homework. Let's say now we have something a little bit different. We have something called the percentile rank. Okay, percentile rank only goes from 0 to 100. And what it is if you're looking on your curve, 0 is way down here, all the way up to 100% up here. And you're able to put things in order. So if you've ever been to like the doctor's office, and they say when you're little, and they look at your height, and they look at a chart, and they say, oh, you're in the 85th percentile for your age and height. That's what they're doing. If they take all the people with heights, you're taller than 85% of them. To find the percentile rank, there's going to be 2 cases. If we're above the mean and if we're below the mean. So we'll take a look here, though. We'll kind of address each one. If the heights of 16-year-old teenage boys are normally distributed with a mean of 66 inches and a standard deviation of 3 inches, we want to know if Jake is 72 inches tall, we want to know his percentile rank. So what's the first thing, before we even look at really the problem, what do we see? Normally distributed. So we see normally distributed. So we come over to our reference sheet and we draw a chart. All right. We're going to draw a chart. Everybody get the chart drawn. All right. So I'm drawing my normal curve. What am I going to be able to put in here? Sandra, okay, put the mean. Where did I put the mean? Right at 0. Put the mean in at 0. Careful. We go up by 1.5. What do we go up by 1.5? Yep, this is half a standard deviation above the mean. So what is half a standard deviation above the mean?
Which way would you go?
67.5. We can really go either way we want. This right here is going above. It means we're adding to the mean if we're going up. If we're going down to these negatives, we're going to be subtracting it from the mean. Now, in this case, we're going to want to fill out the whole curve here. So we'll go above the mean first. So 67.5. What's the next one? 69. And then 70.5. 72. 73.5. 75. Let's get below the mean done also. What's 0.5 standard deviations below the mean? 64.5, 63, 61.5, 60, 58.5. 58.5. All right. So we got our curve filled in. We want to know the percentile rank of a 72-inch person. So what I do is just like I was doing when one of his homework question with those like percent more than or percent less than, I like to draw a line right at my divider. So I draw my line right at 72 in this case. And then we're looking, remember, for percentile rank, it starts here at 0, then it goes up to all the way over here is going to be 100. So what I want to do is I want to get everything over here. And the way I do that, the easiest way to do that, when you're above the mean in percentile rank, just add up everything to the right and then subtract it from what? 100. So what do I add up in this case? 19, what was it? We're going to add up everything to the right. Everything to the right. Everything to the right of whatever divider we're looking at. Yep. 1.7, 0.5, and 0.1, so we get 2.3. 2.3%. If we want to know our percentile rank, what do? 100% minus 2.3 is going to be 97.7%. That's our percentile rank, 97.7. All right. Not that bad. The real key is remembering if your value that they give you, whatever value you're trying to find it for, is above the mean, you do 100 minus. Now let's take a look. The next slide, part B, we're going to be below the mean. So we take everything below. So in this case now, it's the same thing. Our mean is 66, our standard deviation is 3. But now we want to know if Scott is 60 inches tall, what's his percentile rank? So we'll come back over here, and of course, everything got wiped out. So the mean is 66, and this is 64.5, 63, this is 60. I'm just going to fill in some of my numbers back in. You guys, you don't have to redraw a new normal curve for this. This is the same problem, same data. You can use the same normal curve that you just drew. Okay. So we're looking 60 inches tall. Where am I going to draw my line? Right at, yeah, -2, 60. When we plug it in. And this time, I'm going to count up everything where? To the left of that line. Yep, exactly. And what does that come out to? Yeah, if I add 1.7, 0.5, and 0.1, 2.3%. Do I need to do 100 minus this time? No, I don't need to. If I'm below the mean, I just count on the left, and that's it. If I'm above the mean, I count on the right, and then do 100 minus. That's really all there is to this. At 2.3, yep. 2.3 percentile rank. So that's like for heights, only 2.3% of people are shorter than this guy Scott. But for our first example, when it was Steve, 97.7% of people were shorter than him. In other words, it's like lining everybody up. That's what the normal curve does. Like they were talking about in that video, they put all the fish in by length, and most of them were here, and some of them were over here, and some of them were over here, the really tall ones and the really short ones. everybody give this one a shot. The next thing, we recall the king crab problem, where we had the mean weight of 12.6 for our crab population, and a standard deviation was 1.5. And this time we want to know the percentile of a crab that weighs 14.1 pounds. All right, we look like we're finishing up. So I know it's a normally distributed population. I'm going to draw my normal curve. Help me fill it in. Where 0 is, I'm going to put in 12.6. That's the what? The mean. And then it tells me that. What else is the problem, Tom? Standard deviation is 1.5, so what is half of a standard deviation? 0.75. So 0.5 standard deviations above the mean is 13.35, and one standard deviation above the mean, 14.1. Okay, and I could fill in more of my curve, but really I found what I was looking for, right? I found that 14.1. Put my line in right there, and I want to find a percentile rank. Where are we, above or below the mean? Or above the mean. What's the rule for above the mean? Add up to the right and subtract from 100. So I'm going to add up what? 9.2, 4.4, 1.7, 0.5, 0.1. Don't forget about that 0.1. Don't forget about that 0.1. So we add them all up. What do we get? 15.9. So 15.9, but we're not quite done yet. Yeah, we have to do 100 minus that to find our percentile rank. What is it? We're in the 84th.1 percentile. We're in the 84th percentile. So what does that mean as far as the weights of these crab? Where does a crab that weighs 14.1 pounds lie? In kind of words. It lies in the 84th. Yeah, but what is... Yeah, it weighs more than 84% of the other crabs. That's what the percentiles are. All right. Let's head back to this one we skipped earlier, 2.1. So the scores on a test have a normal distribution. The mean is 40, and we got a standard deviation of 6. We want to find the probability that a score chosen at random lies between 34 and 46, all right? What kind of question is this? Is this what is it? Am I going to do percentile rank or no? No. This is like what we did in the homework yesterday. We got to find the interval. Go ahead and do it. And, you know, I'm actually going to send it as a quick poll. Does that pop up for you again? Right. Yeah. So just give me your answer. Just do the work, and I'll collect them. All right?